Good morning students. In the previous class, we see how to use the partial fraction. Now we continue the same model sums. In same exercise 11.5, we see the question, integrate the following with respect to x. So this is our question. Now we integrate the term with respect to x. This is our question. Now we write it simple. Integrating of 3x minus 9 whole divided by x minus 1 x plus 2 x square plus 1 into dx. Now we integrate the term. You see, the word using partial fraction is not given here. So we must understand, we solve this problem by using the concept of a partial fraction. Because directly there is no integration formula of this term. You see, the denominator fully there will be a product of 3 factors. So directly there is no formula of this integration. But it is a proper fraction. The degree of the numerator is 1, degree of the denominator is 4. So it's a proper fraction. So using partial fraction. Now we consider the term first of all. Okay, we consider the term. So consider 3x minus 9 whole divided by x minus 1 x plus 2 and x square plus 1. Now we partial fraction here. We already tell each and every linear factor there is a constant. You see the first linear factor x minus 1, so we put one constant. So a divided by x minus 1 plus. We insert the symbol plus. Second linear factor x plus 2, so we insert the symbol again b. b divided by x plus 2 plus. Wow. Now you see it is not a linear factor. It is a quadratic factor. X square plus 1, and also we can't split into a linear. A linear means the coefficient of x should be 1 or other than any number, but a square cube is not there. It's called a linear. It's a quadratic polynomial, and also we can't split this quadratic polynomial into a linear factor. So in this situation, how to write? We already tell it is in the third type. Suppose if it is a quadratic factor, x square, okay, so there will be 2 constants occur. The 2 constants occur in which manner? Already we write a, b. Next the constant is c, x plus d divided by x square plus 1. Suppose we can't split the quadratic polynomial, then we write the numerator in this manner. One constant into the given variable plus another constant. We already write a, b, so I add c and d. Suppose we write first it is x square plus 1, so first term. Then we write ax plus b. So now we use this equation, so I put it is equation 1. The next step, to find the unknown constants a, b, c and d. So in this process, we will take the LCM of the denominator. Okay, what is the LCM of this denominator? The LCM of the denominator, you see all the 3 terms are differ. We need a LCM. So we multiply all the 3 terms. X minus 1, x plus 2, x square plus 1. So it is the LCM of the denominator. In first term, numerator is a. The first term denominator is x minus 1, but it is a LCM. So what are the missing factor? X plus 2 and x square plus 1. So the term is multiple with a. So a of x plus 2 into x square plus 1. Next, plus the numerator constant is b. The denominator of b is x plus 2, but it is the LCM. So what are the missing factor? X minus 1 and x square plus 1. So x minus 1, x square plus 1 plus. Okay. In third term, already the third term numerator is cx plus d. So Cx plus D. Cx plus D, denominator is x square plus 1, but it is our LCM. Okay, this term is already there. These two factors are missing, so the missing factor is multiple with the numerator. So x minus 1 into x plus 2. In LHS, no change. We write as it is 3x minus 9 whole divided by x minus 1, x plus 2, x square plus 1. Now you see in both the LHS and RHS, the denominators are same. So I cancel. Both the denominators are cancelled. Remaining is 3x minus 9 in LHS is equal to RHS. A of x plus 2 into x square plus 1 plus b of x minus 1 into x square plus 1 plus cx plus d of x minus 1 into x plus 2. Now we put any values of x. Now we have one equation. Our motive is to find the unknown constants a, b, c and d. So we put in which value of x, we find alone the value of a, b, c and d. We already see our two sums. Now we have any idea? We put in which value of x, the three constant will be vanish and one constant is possible. We check. One value of x is minus 2. Suppose we put the value of x is minus 2, you see a vanish. Here minus 2, this all vanish. This one is possible, so b is possible. I will check another value. Suppose we replace the value of x is equal to just 1. 1. B of 1 minus 1, 0. So b value is 0. 1 minus 1, so this all values are 0. But here some values. Okay? So it's our choice, we put any value of x, but it is the easiest value. Now using this equation to find the constants a, b, c and d, and we substitute these values of a, b, c and d in the first equation. Okay? In the first equation. Then integrating on both sides, we get the result. What is the reason partial fraction used here? Directly there is no formula of this term, and also is a proper fraction. So using the concept of a partial fraction, we solve the sum. And now we put this equation is at 2 because so many values are given here. So I put it is equation 2. First I understood to find the value of the constant a. So first I need the value of a. All the remaining values should be vanished. So I put the value of x is 1, you see. 1 minus 1 is 0. Here also 1 minus 1 is 0. So put x is equal to 1 in 2 in the second equation. So whenever x is there, we replace x by 1. So 3 of 1 minus 9 is equal to a of the value of x is 1. 1 plus 2. The value of x is 1. The value of 1 square is also 1. So 1 plus 1 plus b of just I write 0. Because 1 minus 1 is 0, other than 0 is always 0. 0 and anything is always 0, so I add just 0. Plus, actually c of 1 plus d, okay. C of the value of x is 1 plus d. All other values are 0. 1 minus 1 is 0. 1 plus 2 is 3, but 0 and 3 is 0. 0 and anything is always 0, so just we write 0. So all terms are cancelled. Here also cancelled. 3 minus 9 is equal to a of 1 plus 2, 3. 1 plus 1 is 2. All the remaining values are 0. So 3 minus 9 is a minus 6 is equal to 6a. Okay? 3 2s are 6a. 6 6 are cancelled. Minus 1 is equal to a. So the value of a is minus 1. So we find the value of the constant a, the value of a is minus 1. Next, to find another constant, our easiest value. Suppose we replace x by minus 2 here. Minus 2 plus 2 becomes 0. Here there is no 2 term, so b value is possible. Here we see minus 2 plus 2, all values are 0. So again we put x is equal to minus 2 in the second equation. So in second equation, whenever x is there, we replace x by minus 2. So 3 of minus 2 minus 9, okay? 3 of minus 2 minus 9 is equal to a of, just I write 0, okay? Minus 2 plus 2 is 0. 0 to anything is always 0. Plus b of, this value is possible. The value of x is minus 2. Minus 2 minus 1. X square, the value of x is minus 2. Minus 2, the whole square is 4. Plus 1. Plus actually, c of minus 2 plus d, okay. C of the value of x is minus 2 plus d. Minus 2 minus 1. Here minus 2 plus 2. Minus 2 plus 2 is 0. So this value is 0. And first value is also 0. 3 into minus 2, minus 6, minus 9 is equal to b of minus 2 minus 1 is minus 3. 4 plus 1 is 5. Minus 6 minus 9 is a minus 15 is equal to minus 3 into 5 is minus 15. Minus 15 into b is a minus 15b. What about b? The value of a b is just 1. Minus 15 minus 15 both are cancelled. The value of b is 1. So just 2 value of x is only possible. So we substitute these 2 values. But to find the remaining 2 constants also. What are the remaining 2 constants? C and d. So except these 2 values, no one value cannot be vanished. So the next step is to find the constant c or d using the relevant value of x. But here the value of x is also easiest. Suppose we replace the value of x is 0. Okay, 0. C value only vanish. All the remaining values possible. But we already find the 2 constants. So the next step, I replace the value of x is equal to 0 in the second equation. So put x is equal to 0 in 2. So whenever x is there, we replace x by 0. You see, it is the second equation. So 3 of the value of x is 0. So 3 into 0 minus 9 is equal to a of, okay, whenever x is there, we leave because the value of x is 0. So 0 plus 2 is 2. 0 square plus 1 is 1. So I write it is a of 2 into 1 plus b of the value of x is 0 minus 1 is minus 1. 0 square 0 plus 1 is 1 plus c of the value of x is 0 plus d into x value is 0 minus 1 minus 1. 0 plus 2 is 2. So in equation 2, whenever x is there, we replace x by 0. So 3 into 0 is 0. So minus 9 is equal to a of 2 ones are 2 plus b of minus 1 into 1 is minus 1 plus always that one because c into 0 is 0 plus d of minus 2. So minus 9 is equal to 2a minus b minus 2d. Now we substitute the values of a and b. We already find the value of a and b. The value of a is minus 1 and the value of b is 1. Using this value in this equation, so minus 9 is equal to 2 of a minus 1 minus the value of b is 1 minus 2d. Minus 9 is equal to 2 into minus 1 minus 2 minus 1 minus 2 minus 1 is a minus 3 minus 2d. The minus 3 term becomes that side plus 3 Minus 9 plus 3 is a minus 6. So minus 6 is equal to minus 2d. We cancel in the second equation. So the value of a d is 3. I need some place to find another constancy. So I put in side out. So minus 3 becomes the side, plus 3, minus 9 plus 3 is minus 6. I cancel in the second table 3 times. Both are minus, so the value d is equal to 3. Okay, to find the constant 3, a, b and d. But to find the another constant c also. So there is a two-way. The one is equating the coefficient of c term occur. Or the another way, except these 3 values of x, we put any value. But the value is very easiest. Suppose we put the value of x is 5000, 5000 is also possible. But the process is very complicated. So suitable value of x we substitute. Or we equating the coefficient of a c term occur. Is a better and also it is the easiest. So equating the coefficient of c term. Okay. Now you see the second equation. C term only we find. Here x. Suppose we multiply all the 3 terms. What is the x highest power of x? X into x is x square. X square into x is cube. We need to find the value of the constant c. So we equating the coefficient of x cube. Equating the coefficient of x cube term on both sides. Now you see in LHS, okay, it is the equation to LHS, there is no coefficient of x term, x cube term. Coefficient of x cube term is nothing, so 0. You see in the first term, we multiply x into x square is x is cube, so coefficient of x cube is a. Second term, x into x square is x cube, so b. C is possible. You check D is possible? D is impossible because we multiply these two x into x is just x square term only with. So in coefficient of x cube we equate. LHS is there is no coefficient of x cube term, so 0. Here only one term is possible, so a x cube, so coefficient is a, b and c. So 0 is equal to a plus b plus c. Okay, a plus b plus c. So 0 is equal to the value of a minus 1. The value of b we already find, that value is plus 1 and c. So minus 1 plus 1 is cancelled. The value of c is 0 because one is minus 1, another one is plus 1. So both are cancelled. The value of c is equal to 0. What is the next step? To substitute these values of the constant a, b, c and d in the first equation. We already write the first equation. In this first equation, we substitute these values of a, b, c and d. The first equation is LHS 3x minus 1 divided by, no change. In RHS, a, b, cx plus d. The value of a is minus 1. The value of b is 1. The value of c is 0 here. In all the time is not 0, but in this sum the value of c is 0. 0 dx plus 3. Okay. The next step is taking integration. So integration of 3x minus 1 divided by x minus 1 x plus 2 into x square plus 1. We integrate the term with respect to x. Okay, so dx is equal to actually 3x minus 9. My integration of minus 1 divided by x minus 1 plus 1 divided by x plus 2. I leave this 0 term. Okay, 0 to x is 0 plus 3 divided by x square plus 1 into dx. For understanding, I will be multiplying dx term inside. In first term, minus is common, so I will take outside minus 1 divided by x minus 1 plus integrating of 1 divided by x plus 2 plus. Now you see the third term, The constant 3 is less. So I will take outside the constant 3. 1 divided by x square plus 1 into dx. We split in the 3 integration separately, and also the term dx is common, but we have some mistake. You put just a dx term in that. You see the first one, second term is also we must write dx, because we are integrating with respect to x. If suppose we don't put dx here, it is meaningless. So we must write dx here also. You see directly there is a formula. Minus integrating of 1 by x is log of modulus x. So 1 by x minus 1 is log of modulus x minus 1 plus log of modulus x plus 2 plus 3. You remember the formula? Direct formula. Is x square plus 1 or it is 1 plus x square, okay? We say it is x square plus 1 or 1 plus x square also. So the formula is tan inverse of x plus c. So it is the answer. We leave as it is. Or, sir, I need the book answer. So in your question or in your test or example, I leave as it is, no problem, so no reduce the mark. Suppose I need exactly the book answer. You see the formula of log. Log m by n, you know the formula? Log m minus log n is log m by n. Actually it's a positive term, it is negative term. We treat it is the first term. Log m minus log n. Log m minus log n formula is log m by n. So we write it is log modulus x plus 2. Log m by n formula we used here. So we write it is log modulus x plus 2 divided by modulus x minus 1 plus 3 tan inverse of x plus c. I write the formula log m minus log n. The formula is log m by n. We use the formula here. So it's a m term, it is n term. So log m by n. You see the modulus is common in both the numerator and denominator. So we write it is only once log of modulus x plus 2 divided by x minus 1, okay, plus 3 tan inverse of x plus c. Actually some big sum, but you know all the concept and also a formula. The sum is very easy to derive. Okay, now we move the next sum, 20. Now we integrate the term x is cubed divided by x minus 1 into x minus 2 into dx. We integrate the term. Now we consider first of all the term x is cubed divided by x minus 1 into x minus 2. Now you see it is not a proper fraction. It is an improper fraction because the degree of the numerator is 3 and the degree of the denominator is just 2. So partial fraction is possible only when the given fraction is proper. But it is improper, so it's a fourth type. So first we convert the improper become a proper. So there is a chance. So improper become a proper. So in this purpose, first of all, I expand the denominator. X into x is square. X into minus 2 is minus 2x. Minus 1 into x is minus x. Minus into minus is plus. 2 ones are 2. We converted the improper become a proper. So we do this one. So we expand the denominator. Minus 2x minus x is become minus 3x. So x is cubed divided by x square minus 3x plus 2. Now we divide the numerator by the denominator term. Why? To convert it into the proper. So we divide the numerator by the denominator. The numerator is x cubed divided by the denominator is x square minus 3x plus 2 is x cube and here x square. In which term we multiply x square, we get x cube is x. So now we multiply the term x with these three terms. X into x square is x cube. X into minus 3x is minus 3x square. Plus 2 into x is 2x. So we separate minus plus minus. So these terms are cancelled. So we change the symbol, so it is a 3x square. Actually it is minus 2x. Again x square is improper. So we divide one more time. Here we see what is the first term, x square. Here 3x square. We multiply in which term x square, we get 3x square plus 3. So plus 3. Now we multiply the number 3 with these three terms. 3 into x square, 3x square. Minus into plus is minus. 3 3s are 9, so 9x. 2 3s are 6. Again we separate. Minus plus minus. So the terms are cancelled. 9x minus 2x. 9x minus 2x is 7x. Okay, 7x is actually is become minus. So minus 6. Now we see the denominator degree is x power 2 and the numerator degree is x. So it is proper. So it's improper fraction. How to convert the proper means first we write the quotient. Okay, it is a quotient. Plus remainder divided by the divisor. Okay, remainder divided by the divisor. So we write in this manner, the improper become a proper. So now we write, therefore x is cube divided by x square minus 3x plus 2 as quotient. What is the value of the quotient? The value of the quotient is x plus 3 plus remainder. Actually it is the remainder. 7x minus 6 is a remainder divided by again the divisor. X square minus 3x plus 2. Now we convert, therefore we write again in factor form. X minus 1 into x minus 2 is equal to x plus 3 plus 7x minus 6 divided by x minus 1 into x minus 2. Now integrating on both sides. So integrating of x is cube divided by x minus 1 into x minus 2 is equal to x plus 3 plus, actually we are integrating 7x minus 6 divided by x minus 1 into x minus 2 into dx. You see the first two terms directly there is a formula. Integrating of x is x squared by 2. Integrating of 3 into dx is 3x. Now we integrate that term only. So now we consider that term now. So the integrating of x is x squared by 3. It is 3x. We consider the term. Again we do the same partial fraction because it is the proper fraction. The degree of the numerator is 1 and the degree of the denominator is 2. We do the same work to find the unknown constants a and b. And now we consider the term 7x minus 6 divided by x minus 1 into x minus 2. Both the factors is a linear factor. Each and every linear factor there is a constant. So first factor is x minus 1, we have the constant a, plus the second linear factor is x minus 2, so we have the constant b. So b of x minus 2. The next step is taking the LCM of the denominator of the RHS. So just 2 times x minus 1 into x minus 2. So we cross multiply or taking LCM. Just 2 times, both the terms are differ. So we multiply the 2 terms as it is x minus 1, x minus 2. So a of x minus 2 plus b of x minus 1. In LHS no change, 7x minus 6 divided by x minus 1 into x minus 2. Both the denominators are same, so we cancel LHS, RHS denominators. What is the remaining numerator? 7x minus 6 in LHS. RHS is a of x minus 2 plus b of x minus 1. The next step to find the constants a and b. Easily we put the value of x is equal to 1, b vanish to find the value of a. And we substitute the value of x is equal to 2, a vanish to find the value of b. So the next step, we put the value of x is equal to 1. We put the equation 1, 2 like this for our understanding. If you know very well, we write one by one step. So we put the value of x is equal to 1 in this equation. Whenever x is there, we replace x by 1. 7 of 1 minus 6. A of 1 minus 2 plus b of 1 minus 1. So 7 minus 6 is equal to a of minus 1 plus b of 0. 7 minus 6, 1 is equal to a into minus 1, minus a. The value of a is minus 1. Next, we put in which value of x to find the constant b? Is easily we put the value of x is equal to just 2. We put the value of x is 2, we find the value of a. So, put x is equal to 2. 7 into 2 minus 6 is equal to a of 2 minus 2 plus b of 2 minus 1. 7 2s are 14 minus 6 a of 0 plus b of 1. We leave this. 14 minus 6 is 8 is equal to b. So the value of b is 8. So to substitute this value in this equation, therefore 7x minus 6 divided by x minus 1 into x minus 2 is equal to a. The value of a is minus 1 by x minus 1 plus the value of b is 8. So divided by x minus 2. So the value of 7x minus 6 divided by that one is exactly this one. So I write this step. So instead of 7x minus 6 divided by x minus 1, x minus 2, we write this a partial fraction. Okay, we continue the sum. LHS x is cubed divided by x minus 1, x minus 2 into dx. Okay, we write this as dx. X plus 3, no change the first two term. Okay, x plus 3 plus 7x minus 6 divided by x minus 1 and x minus 2 is nothing but this partial fraction. We are using this value. Actually the symbol is plus, but the first term is minus. Plus into minus is minus. Minus 1 divided by x minus 1 plus 8 divided by x minus 2 into dx. For understanding purpose, I don't rough this step. Now using this value is nothing but that one. So now I rough that step. Now I integrate each and every term one by one. Actually we split each and every term, or we integrate directly. I integrate directly the sum. The first step is x. Integrating of x is using the formula of x power n. The integrating of x is x square by 2. Plus 3 into dx. Integrating of 3 into dx. 3 is a constant. And integrating of dx is x. Minus. The sign minus is there. So minus 1 by x minus 1. Integrating of 1 by x minus 1 is a log of modulus x minus 1. Plus. Next symbol is plus. 8 divided by x minus 2. In 8 divided by x minus 2, 8 is a constant. I will take outside 8. The remaining formula is log of modulus x minus 2 plus c. So now in this class we see just two sums. The first one is important 5 mark big sum, and the second one is using the concept of improper become a proper. Now the same model sum lies in example also. We must try in our class note.